Temporal interframe pattern analysis for static and dynamic hand gesture recognition, proposed by Kaoning Lijun and Tianyang Wang. In the recent decade, the performance of hand gesture recognition has been significantly improved. However, there is still a non-negligible gap between lab experiments and real applications. Therefore, every 1% of improvement is highly desired. In this paper, we propose a three-level scheme to utilize the temporal interframe pattern on the recognition of both static and dynamic hand gestures. So is there temporal information of static hand gestures? The answer is yes, because a human user would not change the hand gesture unreasonably. In another word, a human would not show a static hand gesture out of context. If the hand gesture classifier works correctly, there should be no abrupt change between gestures. If such abrupt change happens, most likely the hand gesture classifier has made an error. The figure shows an example. An error in the hand gesture classifier caused an abrupt change in the sequence of static hand gestures, and this faulty sequence is obviously different from a real transition between two different gestures. With proper analysis of the temporal patterns of the consecutive frames in the sequence of static hand gestures, we will detect the abrupt changes and then correct the errors. The overall accuracy of recognition will be improved. So here we design a two-level classifier for static hand gestures. If we input the labels of the hand gesture of one frame and the labels of its previous frames to a classifier as the training data, the classifier will learn the different patterns between incorrectly labeled frames and the real transition of hand gestures. The first classifier C1 gives the class label to every frame of the image sequence, whereas the second classifier C2 uses the labels generated by the first classifier to detect and correct the mistakes. So this is a diagram of two-level classifier. So any classifier that is relatively robust can be used as C1. And to reduce the detection latency, the class label of the current frame and its four previous frames are used as the input of C2. This is because in a real-time application, a latency greater than 120 milliseconds will affect user experience. And let's assume the camera captures the image at 30 frames per second, then 120 milliseconds is 4 frames. And on the second level, Bayesian network is used as the classifier of C2, and it has the best performance in our experiments. So given the two-level classifier of static hand gesture, we want to extend it to the recognition of dynamic hand gestures. A dynamic hand gesture of finger movements can be considered as a temporal sequence of static hand gestures. Therefore, a temporal sequence may be a single dynamic hand gesture or a video sequence of several static hand gestures. Therefore, we would only trigger a classifier for dynamic hand gesture when the class label of static hand gesture of the current frame is different from the previous frame, or when the coordinates of the hand suddenly changes. As demonstrated by Hu and Yin, using a sequence of labels as the input data for dynamic hand gesture recognition worked better than using the features directly extracted from the original image sequence. Therefore, the temporal sequence of labels generated by C2 is used for dynamic hand gesture recognition. And therefore, we construct a third classifier, and the hidden Markov model classifier is used as C3. So here we have the complete framework of three classifiers. The original image sequence is the input to classifier C1, and it generates a class label for every frame, and then the sequence of labels will be sent to C2. C2 would use the label of the current frame and 4 of its previous frames to do a correction, and after that, the corrected static hand gesture class labels are sent to a trigger. If it triggers nothing, then the static hand gesture labels are kept, and then the sequence will be identified as a sequence of static hand gestures. If the trigger is triggered, then the classifier for dynamic hand gesture is used, and the sequence is sent to the dynamic hand gesture classifier, and then a label of dynamic hand gesture is given. In our experiment, we have a dataset of 16 static hand gestures and 7 dynamic hand gestures. There are totally 3,438 samples from 17 different people. Without C2, the accuracy of C1 is 91.9%, while C2 improves the static hand gesture recognition to 98.1%, and that's 6.2% improvement. And 97.5% of the dynamic hand gestures were correctly distinguished from static hand gestures, and the HMM classifier C3 achieved an accuracy of 98.3% across the 7 dynamic hand gestures. This makes the overall accuracy of dynamic hand gesture recognition reach to 95.8%. So here shows a list of some of the references. And if you have any question, please send an email to me. My email is kaoning.hu@tamuc.edu. Thank you.